Okay, so this video is about surds, and before discussing surds, let's first recall the concepts of roots. We know that there are certain roots which can also be written as rational numbers. For example, if I write root 4, so root 4 can also be written as a rational number as 2. Why? Because we know that square root of 4 or under root of 4, it's a 2. Same is the case of maybe 25. Under root 25 can also be written as a rational number because we know that square root or under root of 25, it's a 5 only. So there are certain numbers whose root gives us a rational numbers, but at the same time, we have numbers in root form which doesn't give us a rational number. For example, under root 7 maybe, or under root 10 maybe, or under root 11 maybe. So all these numbers are the ones whose root, when done, will not be giving us a rational numbers. So these numbers, which cannot be written as rational numbers in math, are called as surds. So to define surds properly, these are the numbers in root form which cannot be written as rational numbers. Okay, and in maths, surds are also called as radicals. So surds are also called as radicals. So, like all the different numbers, surds also have all the mathematical operations involved. When I say mathematical operations, that means it would be the addition, subtraction, multiplication, and division of the numbers in the surd form. Before discussing all the mathematical operations, we need to know how a simple surd form or a simple surd number can be simplified. So first we'll have a look at the simplification of a number in the surd form. So the first thing is we are looking for the simplification of a number in surd form. This is the first thing we are looking at. So let's pick up a few examples that will help us in understanding how a number in surd form can be simplified. Let's say we have the numbers as we have two different numbers. Under root 24 and under root 700. So let's work it out for under root 24 first. Now to simplify a number in surd form, we need to know the concept of prime factorization. If you don't know the concept of prime factorization, then please refer to my previous videos based on prime factorization. So here, how prime factorization is done, we'll start finding the prime factors of 24. Now we'll do that, we'll keep on dividing this 24 by the prime numbers. So we'll start with the smallest prime number, which is 2. So 2 12s are 24. 2 6 are 12, 2 3s are 6, and 3 cannot be divided by 2, so we look for the next bigger prime number, which is 3. So 3 ones are 3. And then we pick up powers of 2, or we pick up pairs here. So when I say pair means we have only this one pair formed. So pair means the two factors should be same in that pair. So this 24, I can write this 24 as, we have one pair of 2. So I can write this as 2 square into another 2. And then we have one more 3 here. So this is how we prime factorize, and this is how we write a number in root form as a product of its prime factors. And we know that square root of 4, it's a 2. How? Because we know that 4 can be written as 2 square, and eventually what happens is this square on 2 cancels the root and comes outside the root. So same technique would be applied here. This 2 having the square would cancel the root on itself and come outside the root. So eventually only this 2 having the square would cancel its part of root and come outside the root, and this can be written as 2 under root 2 and 3. Now the remaining factors 2 and 3 inside the root, they cannot be simplified, they cannot be taken outside the root. So they remain inside the root and they eventually get multiplied. So the final answer is 2 under root 6. So this is how we simplify a number in surd form. Let's pick up this another example, which is under root 700. Now, under root 700, again, we'll do the same thing. We'll find the prime factors first. Because without knowing the prime factors, we won't be able to simplify. So for 700, we start with the lowest prime factor, and we can start with 2 here. So 2 into 350 are 700. And then 350 divided by 2 would give us 175. After reducing by 2, 175 cannot be divided by 2, so we look for the next bigger prime number. And next bigger prime number here, what we can see is 5. So 5 3s are 15, 2, 5, 5s are 25. This 35 can again be divided by 5, so this can be written as 5 7s are 35. And 7 cannot be divided by 5. So we look for the next possible bigger prime number, which is eventually a 7 only. So 7 ones are 7. So here, for all these prime factors, we again have to pick pairs of 2. So we can see this one pair, another pair of 5. So altogether we have 2 pairs formed here. This 700 can be rewritten as 2 square into 5 square into 7. And like the previous example, the numbers who are having a square will go outside the root. So 2 square and 5 square having a square will go outside the root. So this can be written now as 2 into 5 into under root 7. And 2 and 5 being outside the root, they can be multiplied and giving the answer as 10 root 7. So this is the answer in the simplified form. So this is all about simplification of a number in surd form. The next thing about surds is we should be knowing uh, the rules involving surds. And before uh, looking at the rules involving surds, we can see the addition and subtraction of the numbers in the surd form. So next thing we are looking at is addition and subtraction. Addition and subtraction of surds. Multiplication and division we'll look later, and for multiplication and division there are certain rules to be followed, so we'll do that later. Now for addition and subtraction, we have to recall the concepts of algebra learned previously. For algebra, we know that two terms or two numbers can only be added if they are like terms. For example, if I write 2x plus 3x, they can be simplified, they can be added, giving us a 5x. Why? Because they both were the like terms. But if I write 2x plus 3y, this cannot be simplified further. Why? Because the two terms are not having the same variable, the two terms are not same. So 2x and 3y cannot be added. So same is the concept what we'll be following for the addition and subtraction of the numbers in surd form. We can only add or subtract the number in surd form when they have the same radicals part, when they have the same surd part. So what we'll do first is we'll first simplify the numbers in the surd form. And after simplification, we'll see if the numbers are having the same radical forms or not. If the numbers are having the same radical form, then only we'll add or subtract the numbers. Otherwise, we won't be able to add or subtract them. So again, we'll refer to a few examples here. The question remains the same. It's about simplify only. The question still remains the same. It says simplify. Okay, now these two surds or these two numbers, they are not having the same radical forms. So we look for the simplification of each number in the surd form. Under root 7 is already in the simplified form because 7 cannot be simplified further. But for 63, we can see some simplification to be done. And we'll do the prime factorization here for 63 only. So for 63, we start with the lowest prime number, which is 2, and 2 doesn't divide 63. So we look for the next possible prime number, which is 3. So 3 2s are 6, 3 1s are 3, 3 7s are 21, and now the next prime number to be picked is 7. So 7 1s are 7. So this root 63, 7 remains as it is, and this root 63 can be written as 3 square into 7. Now 3 having the square, as discussed earlier, will go outside the root, giving us 3 root 7. Now here again, you can see, like the case here, it was 2x and 3x having the same variable part. They were added. So same goes the case here. Root 7 here and root 7 here. They have the same radical part or the same surd part, so they can be added. Root 7 only means since there is no number outside the root 7, that means it's a 1 here. So they can simply be added as 1 plus 3. So 1 plus 3 gives us a 4, and then this root 7 remains as it is. So 4 root 7 is the final answer here. Let's pick up one more example. Again, the question says simplify only, because simplify means we look for the possible addition, subtraction, multiplication, and division. Now, in this example, both the numbers in third form, they both can be simplified first. So let's first look for the simplification of under root 20. So under root 20 means 20, we'll find the prime factors. So you start with 2, 2 tens are 20, 2 5s are 10, and then 5, 1 is 5. So this root 20 can be written as, and we can see we have a pair of 2. So root 20 can be written as 2 square into 5. Moving on for the next number, which is under root 45, we'll do the same thing. We'll try to find the prime factors for root 45. We have to start with the smallest prime number, which is 2, and 2 cannot divide 45, so we look for the next possible bigger number. So next possible bigger number, it's a 3. So 3 into 15, 3 into 5, and then we go for 5. So 5 ones are 5. So here again we can see only one pair formed, which is of 3. So this root 25 can be written as 3 square into 5. Now simplifying it further, we'll get this as 2 under root 5 plus 3 under root 5. 2 and 3, they simply would be added as 2x plus 3x, which is 5x. They would be added as 5 under root 5. Okay, so surds, it's not about addition, subtraction is not about adding or subtracting the two numbers only. It is possible that we might be asked to add or subtract three numbers as well. For example, here again the question would be saying simplify. Okay, now all these three numbers in third form, we can see some simplification to be done first. So let's start with under root 12. So for under root 12, we start with 2. 2 6 are 12, 2 3s are 6, and then 3 1s are 3. So this under root 12 can be rewritten as, since there is a pair of 2, so this can be written as 2 square into 3 plus. Now about this 3 under root 48, we'll do the prime factorization for 48 now. 48, we start with 2. And for 2, we have 2 24s are 48, 2 12s are 24, 2 6 are 12, 2 3s are 6, and finally 3 1s are 3. Now, now about this thing, or this prime factor, you can see we now have two pairs of 2. So we'll follow the same basics. This 3 would remain outside only. And about this 48, we can write this as, since there are two pairs of 2, we'll write this as 2 square into another 2 square into 3. So this is how we write it. Finally, for root 75, we'll find the prime factors for 75 also. 75 doesn't get divided by 2, so we look for the next prime number, which is a 3. So 3 into 25. 25 cannot be divided by 3, so we look for the next prime number, which is 5. So 5 5s are 25, 5, 1 is a 5. So we see a pair of 5. So here we'll write this as minus root 75 would be 3 into 5 square. So all these square factors will go outside the root. So 2 square into 3 would become 2 root 3 plus 3 remaining outside the surd form. And there are two 2's having the square, so both the 2's will go outside. And this one single 3 remains inside. And for this 3 into 5 square, 5 will move outside, 3 will remain inside. Simplifying it further, we'll get this as 2 root 3. Now these factors 3, 2, 2, they would be multiplied, giving us 3 into 2, 6, 6 into 2 are 12. So plus 12 root 3 minus 5 root 3. And here again, for all these three numbers, we can see we have the same radical part, root 3, root 3, root 3. So 2, 12, and 5, they would be added together. So 2 plus 12, that's a 14. 14 minus 5, that's a 9. So the final answer is 9 under root 3. So this was all about simplifying the surds and addition and subtraction of the numbers in surd form.